Hello everyone, I'm Satesh Kumar from Group 4, and Group 4 we will present about smart irrigation system. So first let me introduce my group members. First is me, myself, Satesh Kumar, son of Gunasegren. Second is Muhammad Zulhilmi. Third is Muhammad Sharil, and the last one is Muhammad Izzat Nakiuddin. So this is the main outline of our project, which is the background, the smart irrigation system circuit, the result we obtain, conclusion, and the references. So let us see the background first. Currently, farmers are facing major problems in their field of agriculture when it comes to watering their crops. This is because they do not have proper understanding of the availability of power. They need to pump water and wait until the field is properly watered, even it is available, which forces them to stop doing other activities that are also important to them, and thus lose their precious time and effort. In order to achieve the maximum use of human power and to obtain maximum profit, there is a need to upgrade different engineering techniques that are being used today. One of the necessary requirements for harvesting a good crop that can be a source of different types of nutrients, whether micro or macro, is to maintain the correct amount of water level in the soil for proper growth. But there is a solution that not only helps farmers but also others to water their gardens, which is an automatic plant smart irrigation system. This automatic irrigation system senses the soil moisture content and switches the pump automatically when the power is on. It is very important to properly use the irrigation system because the main reason for water shortage is the shortage of land reserve water due to the lack of rain and unplanned use of water, as leads to the result of large amount of wastewater. We could use this automatic plant watering system for this reason, and this system is very helpful in all kind of weather conditions like summer, autumn, winter, and other conditions. Rain plays an important role in determining the future of farmers and their crops. The overexploitation of the past years has drastically reduced the level of groundwater. Therefore, it is necessary to use each and every drop of water wisely so that our future generation can also use it. The development of this new technology also help to achieve our goal of sustainable development, which is the clean water, which was set by United Nations. The main objective of this major development and improvement of technology is to develop a smart automatic irrigation system that would use water in a more well-organized way to prevent excess water loss and minimize human effort. Now, let's see the main components of a smart irrigation system. So the main first component is soil moisture sensor module. Second is water pump module. The third is relay module. The fourth is transistor. The fifth is connecting wires. The seventh is light emitting diode LED. The eighth is voltage regulator. The ninth is batteries, the solar panel. In short term, it is power source. And the last one is resistors. These are the pictures of how a smart irrigation system would work, and these are the circuit system. It's just an example. So the smart irrigation system has a broad scope for automating the irrigation system. It does not only automatically irrigates water based on soil moisture level, but also sends that data to server to keep track of soil condition. The system will consist of water pump that will be used to sprinkle water on the soil, depending on the environmental conditions of the soil, such as moisture, temperature, and humidity. Using sensors for data collection and advanced algorithm for scheduling, they will maximize the efficiency of irrigation. They can determine the rate at which the water will evaporate, and based on the estimates, automatically water pump out at the zones in multiple shorter segments of irrigation to maintain optimal soil moisture. They will take into account when the sun sets and rises and what season of the year it is. Some controllers will warn you about the irrigation limitations of your state based on your state code. Sensors and controllers are just part of the picture. Other factors such as water efficient emitters, such as rotors and spray heads must be in place to fully utilize their benefits. A well-designed and installed smart irrigation system can save significant water and money while improving plant health by providing optimal soil moisture conditions. You must have been wondering, how does a smart irrigation system works? So here are how it is works. Most of the soil moisture sensors are designed to estimate soil moisture. Volume water content are based on the soil's dielectric constant. The dielectric constant can be as the ability of the soil to transmit electricity. The soil dielectric constant increases as the soil water content increases. This reaction is due to the fact that the dielectric constant of water is much larger than the other soil components, including air. Thus, the measurement of the dielectric constants give a predictable estimate of the water content. Bypass soil moisture controllers use the sensor's water content information to either allow or bypass scheduled irrigation cycles on the irrigation timer. The SMS controller has an adjustable threshold setting, and the event is bypassed if the soil water content exceeds the setting. So, the threshold for the soil water content is set by the user. So, here is how a digitalized system of a smart irrigation system looks like. There are different types of smart irrigation system. At the core of a smart irrigation system, they are just a sensor-based devices, from sophisticated intelligent detectors to simply manually operated. There are a wide array of different types. The first type is weather-based smart irrigation. The second is soil moisture sensors-based smart irrigation. The third is wind sensors-based smart irrigation.
Hello and Assalamualaikum. My name is Muhammad Sharil and I'm going to present about the system circuit. The smart irrigation system is the essential technology used in many sectors or industries to prevent water scarce and maximize its usage. The first type of smart irrigation system is weather-based smart irrigation. This system will use the local weather data to adjust the irrigation schedules. The four weather parameters that will be observed is the temperature, wind, solar radiation, and humidity. Okay, the next one is soil moisture sensor based smart irrigation. Okay, this sensor will be buried under the plant soil, and it will indicate the content of moisture in the soil. If the soil is too dry, it will send the message to indicate that the soil is dry and need to be watered. If the soil is wet, then it will send the data telling that we should stop watering the plant. Okay, the third one is rain and freeze sensor. This sensor will detect if it will be raining or freezing or during that day, and if the day will be rain or freeze, it will tell that we should not plant the water during that day, because the rain will do the watering process, and if we still water, the efficiency of the watering will be reduced. Okay, the fourth one is wind sensor. This sensor will detect if there is a strong wind outside, or there is a windy day, so that we should not plant the water during that day, because the efficiency of the watering process will be reduced, because the water vapor from the sprinkler will be pushed away by the wind. Okay. Next is component in smart irrigation system. This is the circuit. Okay, the first component that we use is power source. It is used to provide the voltage source for smart irrigation circuit. The voltage is not fixed, so we can adjust depending on the circuit. Next is a relay. Relay is used as a switch to open and close the circuit. It is also this relay also use a magnet to automatically operate the switch. The third one is the soil sensor. Like I explained before, this sensor will detect the content of moisture in the soil, so we can get the data about how we should water the plant. Next is LED. LED will emit light when the current flow through the circuit, so we can make sure that the circuit is functioning. Next is voltage regulator. This IC voltage regulator maintain the output voltage at a constant value. Okay, next the water pump. Water pump is used to pump the water into the drain, so the water sprinkler will sprinkle the water to watering the plant. Next is IC 555 transistor. An integrated circuit chip is used in a wide range of timer, the pulse generation and oscillator application. The 555 can be used to provide time delay both as oscillator and as a flip-flop element. Derivative provide 2, 556 or 4, 558 timing circuit in a single package. The working principle of smart irrigation system. Okay, the system works by sending a signal from the farm controller to the user phone, and the phone must be in an automatic response if the soil needs water. The signal from the phone is sent back to the farm controller to switch on or off the system. It will start the process. The power is supplied and water is pumped out to the sprinklers. It's going to check the moisture level again by the soil detector. If the level is higher than the fixed criteria, there is no need for the irrigation. If the moisture level is lower than the fixed criteria, the irrigation will start over again. After process is completed, it moves to the original state and stop the process. The soil moisture sensor modules used here as equipped with two output pins, digital output and the analog output. The output of the humidity sensor probe is compared to the reference value. The digital pin has an active low output when the soil is wet. The wet detection value can be used while using the analog output to set or adjust to the program itself. As shown in the circuit diagram, a float switch is connected to one of the Arduino analog pin, and a 1000 ohm resistor is used to pull the line up. Arduino analog pin can also be used as digital inputs. Arduino reads the voltage drop across the pull-out resistor to detect the water level in the tank, and the pin connects to the base to the 555 IC transistor, which turn the motor. The grounded sensor all around the land area will give notice for the need of water. Okay, next the factor that may contribute to the failure in smart irrigation system. The first one is clog equipment. Clog may result in a pressure rise that can cause significant damage throughout the irrigation system. Clogs are typically caused when dirt or other debris become launched within the sprinkler head or other outlet. The presence of dry grass in areas that are typically well irrigated or standing water beneath a sprinkler are common signs that a clog may be present. Next, the weather data. If the weather is the local weather send a false report, then it will damage the process of the irrigation system, because we didn't get the right data. Next is the soil data. Soil characteristics such as the condition, the slope, texture, structure, depth, organic matter content, and so on will affect the soil water distribution and root water absorption. Soil variation during the season are important and lead to inaccurate irrigation programming. Ways to reduce failure in smart irrigation system. Number 1, choose the right smart irrigation system which are licensed officially. Second, perform occasional maintenance. Third, check the batteries of any wireless device and the backup power. And the last one, periodically test run the smart irrigation component to ensure equipment is working appropriately. That's all from me. Thank you.
Today, I want to present about results. The system was tested under field conditions and the results revealed that the system would be the best option for medium-sized agriculture. The operational reference voltage amplifier could be modified according to the crop type and the availability of moisture in the field by means of a moisture sensor. Excess power stored in the solar battery and was used when daylight was low. Excess charging prohibited helped to reduce the temperature of the solar battery and increase the battery life. As well as when all probes were wet, it allocated to dry till 2 probes and utilized the water and power sustainable manner. If further reduction of the moisture of the soil occurred, it led to switch on the pump till all probes getting wet. Because of this automated system, water wastage of the tested field could be reduced by 50% of normal irrigation wastage and reduce evapotranspiration by induced ductile operation. Besides, human attention was reduced on irrigation due to automation. Irrigation becomes easy, accurate, and practical, with the impression above set and can be executed in agricultural field in future to endorse agriculture to next level. The output from moisture sensor and level system plays wide role in producing the output. It also can use for domestic uses such as watering houseplant and lawn. That's all from me.
The conclusion for our group project. The smart irrigation system based on soil moisture has been designed and tested successfully. It has been developed with integrated features of all the electronic components used. Presence of every component has been reasoned out and placed carefully, thus contributing to the best working way. The moisture sensor measures the moisture level of the soil. If the moisture level goes to the below desired and limited level, the moisture sensor sends the signal to the Arduino board, which triggers the water pump to turn on and supply the water using the rotating sprinkler. When the desired moisture level is reached, the system halts on its own and the water pump is turned off. Thus, the functionality of the entire system has been tested thoroughly and it is said to function successfully. The smart irrigation system implemented is cost effective for optimizing water resources. The use of solar power in the irrigation system is pertinent and significantly important, also improve their sustainability. Okay, this is our reference to do our group project. Okay, the first reference is from Wikipedia. From this reference, we know what is the function of the irrigation controller. And the second is Cubino Wireless Smart Home. Okay, from this website, we know that the irrigation use up 70% of the water of the earth. So from wireless smart. The more benefit way to use the irrigation is uh, automatic, and in like what we say on the conclusion, which is when the soil is dry or the water humidity is low, then the sprinkler will spray the water. That is the function of the wireless Kibino wireless, because it will use less water, so it will not be membazir like that. Okay, the third is okay. For our third reference, it is about the automatic irrigation system. Okay, this website is tell us about the importance of automatic irrigation system, which is to control the water supply and irrigate the field when it is dry. Okay, and the number 4 is our fourth reference is okay. It talk about the sensor that we use for the automatic irrigation system. Okay, it talk about the sensor that can detect weather, humidity, and others to for the sensor. Okay, for our fifth reference, this website talk about the difference between the weather based sensor and the soil humidity sensor. The sixth reference talk about how the smart irrigation system work and how to set up the smart irrigation system. Our seventh reference is a video that talk about the about the system, the smart irrigation system. It explain how it works and how the sensor detects the water, the humidity, and the temperature. And the our last reference is also a video that talk about the smart irrigation system, but it just talk about the sensor or the systems that been used. Okay, that's all from us. Thank you.